Richard James Mathematics Resources will present Grade 4 Practice Paper 3 Part A. The video presentations are divided into 4 parts: A, B, C, and D. Videos A, B, and C each has 12 problems to solve. Video A, as you imagine, will have the first 12 problems that will go from number 1 to 12. Then video B will go from 13 to 24 and so on. So we will begin at problem number 1. The problem that we have here is already outlined or presented, and some students will say set out in the way that we should solve. And Jerry Lewis will proceed to tell me what it is that we will do to this problem. What are we required to do with this problem?
Add.
How do you know that we are required to add?
Because we have a plus sign.
Okay, so we have a plus sign right here, so we know that we are required to add. Also, the original problem on the paper did not contain the place values of the digits. Those place values were placed there by Jerry Lewis in order that the problem might appear more attractive and also more informative. Begin adding numbers with the rightmost digits. They have the smallest place value. The rightmost digit. The digits to the extreme right. They are the rightmost digit. They have the smallest place value, and we call them also the digits of least significance. The numbers are already given to us in a form that we may go straight ahead and add them. Begin by adding the ones digits. So we will add 5 plus 5, and what is that equal to?
10.
Right, 5 and 5, that's equal to 10. And we may write the 10 down like this: 1, 0. So we may put the 0 here and put the 1 right there. That would not be incorrect. As a matter of fact, it would be correct, because the 0 will go in the ones place and the 1 will go in the tens column. So that will be correct. However, because we have to continue with the addition process, if we place the 1 here, then when we add, it will get in the way of the numbers that we are adding. In this particular case, it is only a single digit. But if we had other numbers to add, the 1 that we put here would get in the way of the other digits that we need to add. It should be in the tens column nonetheless. Therefore, what do? We put the 1 in a safe place where it does not interfere with the other digits. So we will place that at the top of the tens column. And that is why we carry the digit of greater significance to the top of the column. To the top of the column that is located to the left. The very next place value to the left is always 10 times the present place value. So that is why the tens digit of the sum goes to the left, because the place value to the left is always 10 times the present place value. The tens digit of the sum is always carried to the left. The tens digit of the sum is always carried to the left, because to the left we have the place values that are 10 times the present place values. So the tens digit of the sum is always carried to the left. Place the 0 in the ones column and carry the 1 to the tens column. We really intended to put the 1 here, but it will get in the way of the sum and all of the digits that we need to add here. So we put it in the tens column nonetheless, and we put it at a safe place where it cannot interfere with the other digits. Add the tens digits. 1 plus 4, Jerry?
5.
So 1 plus 4 is equal to 5. And place 5 in the tens column. The correct answer is option
D.
Here again, we are required to do what kind of a process, Jerry?
Adding.
Alright, so we are going to be adding those numbers that we have right there. And Jerry will tell us that what is responsible for the adding?
Plus.
Right, we have the plus sign right there, so we are sure that we need to add. And this problem that we have right here is an extension of the problem that we had on the previous slide. So 9 plus 8, Jerry. Jerry is saying that is 17. And as we explained before, we want to write down the 7,
Carry the 1.
and Jerry said that we should carry the 1. Alright, let's carry the 1. So 9 plus 8 equals 17. The place value to the left is always 10 times the present place value. Therefore, the tens digit in a sum is carried to the left. Place the 7 in the ones column and carry the 1 to the tens column. Correct. What is this sum equal to, Jerry?
14. Plus 1, 15.
Right, so 14 plus the 1 that was carried, and that will give 15. So add the tens digits. 1 plus 7 plus 7, that's 15. Now, the same thing applies. We really want to write down this 15 right here. So, the 5 will go right here in the tens column because we are adding tens. So the 5 will go in the tens column. Then we put the 1 right here in the hundreds column. Why? Because the 1 in this number 15 is the digit of greater significance. It is the digit to the left of the 5. And every digit to the left is always 10 times the present place value. What is 10 times 10, Jerry?
100.
Right, 10 times 10 is 100. Therefore, when we add the tens digits, the digit of greater significance will go to the hundredths column, because the digit to the left is always 10 times the present place value. We intended to put it right here, but it will get in the way of the other digits that we need to add. So we put it in a safe place, or the safest place that we can find, which is located to the top of the column. So the 5 will go there, and the digit of greater significance, which is 10 times the present place value, will be placed to the left in the column of greater significance. Add the hundreds digits. What's left? 1 plus 4, and that's equal to 5. Place 5 in the hundreds column. The correct answer is,
557.
and that is represented by option.
A.
The correct answer is option A. This is some significant sum that we have right here. And notice that all of the problems that we have so far in this practice paper 3A are already outlined for us. So we did not have to ensure that the digits are properly aligned and that the decimal points are vertically aligned. All of that was done for us already. So what do we need to do in this particular case again, Jerry?
Add.
And we have those addition signs telling us that we need to add. In this problem, the numbers are already presented in the way that we may add them. Numbers are added beginning at the rightmost digit, which is the smallest place value, also called the digit of least significance. So what do we have here? 3 plus 3 plus 5, and that's equal to
11.
There we have it. So write down 1 and carry 1 to the next column, or we may say the left column or the column of greater significance. What is that sum, Jerry?
6 plus 6, 12 plus 1, 13, and 2, 15.
Okay, so Jerry is saying that that sum is 15. I like when students are capable of doing the addition mentally instead of having to put down strokes and so forth. That shows that students are not familiar enough at grade 4 level with the digits and what they should add to give. But Jerry is familiar with all of those digits, so he can do the addition mentally only. So Jerry said that's 15. So 1 plus 6 plus 6 plus 2, and that's equal to 15. Write down 5 and carry 1 to the more significant place value. So do we just add over here, Jerry?
No, we put down the decimal point.
Oh, right. So he's saying that we need to put the decimal points down. And the decimal point must be vertically aligned with the others. So we will cause the decimal point to be vertically aligned with the others. There we have it. Add the digits in the next column. What's that, Jerry? What's that sum?
15.
15. You can see that easily because this is 5. 4 plus 1?
5.
And there's a 5 and another 5. So we have 3 5s. 3 5s?
15.
Right, so it's as easy as that. 3 5s, 15. And we do what?
Put down the 5.
And carry 1 to the digit of greater significance. And what do we say that sum is equal to, Jerry?
12.
Right. So it's easy because we see 9 plus 1, 10, and then we just have 2 more. So that's 12. That's easy. Add the digits in the next column, which is this one that we have done already, and we carry 1 to the other column. And finally, add 1 and 2 in the last column. What do we get?
3.
Include the dollar sign because we are dealing with currency. So because we are handling money, the dollar sign is very important. The correct answer is
Option A.
option A. What are we required to do in this particular case, Jerry?
Subtract.
We are required to subtract. The subtraction sign tells us that we need to Subtract, it tells us what we need to do. We will begin, as always, at the digits with the smallest place value, at the extreme right. So the rightmost digit, that is what it is called. The rightmost digit to the extreme right. So we have 5 minus 4, and that will give us
1.
So we use 5 diamonds just as an indication. This is what I was telling the students that you should not need to do. But at the same time, the subtraction process can be easier understood if we use objects and manipulate them, so that at this level you understand, or you may have a better understanding of subtraction. Take away 4 diamonds. So when you take away 4 diamonds, what do you notice?
1 is left.
Only 1 is left. So 5 minus 4 is equal to
1.
There is 1 diamond left. And what do we do there? 4 minus 0. If we have something and we do not take anything away, the result is
4.
4. We have 4 things and we do not take any away. If we have 3 and we take 2 away, how many will be left? If we have 3 things and we take away 2, how many will be left?
1.
Okay, good. So 3 minus 2, and that is equal to 1. 3 diamonds, and we are taking away 2 diamonds. And how many diamonds do we have left?
1.
1. The correct answer is option B. Well, at least for this problem, it is not already outlined. But we will have to outline it in the correct way. As a matter of fact, before we can outline this problem that we have here, we have to be able to tell what we need to do in this particular case. So, Jerry, what do we need to do in this particular case?
Divide.
We need to divide. And what tells us that we need to divide is this division sign that we have right here. This is a division problem. Let us set up our division format and use short division. So that is our arrangement when we need to divide. The number that we are dividing into goes here, and the one that we are dividing by will go right here. We first need to say 3 into 1.
I can't.
Well, we cannot do that a whole number of times. Because we cannot do that a whole number of times, we go to the next digit and include it. So we will say now 3 into 15.
5 times.
It goes 5 times, and we place the 5 above the 5. We will first attempt to divide 3 into 1. We can't. Well, we can't do that a whole number of times. So we say 3 into 15 equals 5, and place the 5 above the 5. As a matter of fact, when we said 3 into 1, because it cannot go a whole number of times, what we should really do is put a 0 right here. Then say 3 into 15 goes 5 times, and the answer will contain a 0 and a 5. But because in a whole number, leading zeros do not affect the value of a number, we can go straight ahead without including the 0 there. The 0 there would not be necessary because it does not affect the value of the number. The correct answer is Option
A.
A. We may take an approach that makes use of the fact that division is the opposite of multiplication. And that is the kind of mentality that grade 4 students need to develop. Understand that division is the opposite of multiplication. Therefore, if you are aware of your multiplication table, then you should be able to divide. So we say 15 divided by 3. What does that mean? It means that we need the number that comes right here, that when we multiply that number by 3, the result is 15. So what number do we multiply by 3 and the result is 15? Whatever that number is, it will go right here, and it is the same number as will be if we divide 3 into 15, or we say we divide 15 by 3. So let us say that again. If we are dividing 15 by 3, we say 3 into 15. Saying 3 into 15, we are actually saying what number do we multiply by 3 and the result is 15. So if we know our multiplication table, that number that we multiply by 3, that gives the result of 15, is the number that we need to put right here. If we multiply the divisor by the quotient, the result will be the dividend. What number do we multiply by 3 and the result is 15? 5. 5 is the number that we multiply by 3 and the result is 15. Therefore, 15 divided by 3 is equal to 5. We should have the answer at the tip of our fingers if we are sharp on our multiplication table. See the multiplication table coming up right there, but it will disappear very quickly. So if you do not record the value, then you would have lost it. It's coming up again, and it is going to disappear, because we don't want to break you into any bad habit of having to be dependent on these resources to just do a simple multiplication or division. So we have it. Notice that we have this one coming here. 3 5s 15. Therefore, 5 is the correct answer. Here again, Jerry, we have another problem that was given to us already outlined. In this particular case, what are we required to do?
Multiply.
We are required to multiply. How do you know that?
You have the multiplication sign.
Because of this notable multiplication sign that is present right there. We need to perform the operation as given, and it requires that we multiply the numbers. So how do we multiply? On this occasion, we are also including the place values of the digits. When multiplying numbers, we begin with the numbers at the right. They are the ones with the smallest place values, the digits of least significance. And we are multiplying 7 6s, 42. Write down 2 and carry 4 to the next column. The place value to the immediate left is always 10 times the present place value. That is why for each result, the 10th digit is carried to the left. What do we say next? 7 3s.
21.
Okay. So 7 3s, 21. And we take the 21, and to that 21 we add the 4 that was carried to the 10th column. And we end up with
25.
25. So we will also write down 5 and carry 2 to the next column. We are doing that because of the 2 digits we are multiplying in the tens column. Therefore, this digit is the tens digit. This digit is of greater significance, so it is a hundredths digit. It is therefore carried to the hundreds place value column. Then we finally say 7 ones,
7.
and to that 7 we add 2. So we will have 9 to write down in the hundreds column, and there will be nothing to carry to the next column. The correct answer is
Option D.
option D. Now, this problem that we have, there's no need to give it a particular outline. It may be just written as it is. When adding mixed numbers, the whole numbers are added and the fractions are then added. So what we have here, 3 and 5/12, 7 and 1/12. So while adding, we will put the whole numbers together. And what are these called? These are called, these are the denominator of the fractions that we have there, correct? So, first of all, we add the whole numbers and we pay special attention to the denominators. It is easy to add fractions if their denominators are the same. So we have labeled is your fraction bar, your numerator, and your denominator. The denominator is the lower number in the fraction. If they are the same, while adding the fractions, the answer will be of the same denominator as the denominators of the fractions added, as long as those denominators are equal. When the denominators are the same, the resulting fraction will have the same denominator as the fractions added. So let us put the denominator down. It will be the same denominator as the fractions that we are adding. And the resulting numerator will be the sum of the numerators. So when we are adding fractions, do we add the denominators, Jerry?
No.
We do not add the denominators. The denominators will return and be the denominator of the answer, because those denominators are the same. And what do we do with the numerators?
Add them.
5 plus 1?
6.
So, we add the numerators, and do not forget that while adding the fractions, we have to add the whole numbers, or when adding the mixed numbers, we have to add the whole numbers. 3 plus 7, and that's equal to?
10.
So the answer is 7 and 6/12, and that is represented by option.
D.
The correct answer is option D. There were 134 plums in a box. A child ate 27 of them. That's Jerry. It's a wonder Jerry did not eat all 134 of them. And 10 were spoiled. I don't think that Jerry is speaking the truth. Maybe he also ate the 10 other plums and said that they were spoiled. How many plums were left? So 134 plums in a box. A child ate, let's say Jerry Lewis ate 27 of them. And he said that 10 were spoiled, but I know that what he did, he hid himself and ate another 10. 27 were eaten by Jerry Lewis. If 27 of the plums were eaten, it means that the number is getting less. We therefore need to subtract those 27 plums. So if we have a certain number of plums in a box and we eat some of them, the number remaining will be less. We therefore need to subtract. So let us go straight ahead and subtract. We cannot take 7 from 4 in this mode of subtraction. So we go to the greater place value and rename the 3. Do not forget that the place value to the left is always 10 times the present place value. So when we remove 1 from that 3, we may replace it with 2, but the 1 that we have there is 10 times the present place value. So instead of having a 1, we will have 10. The reason why just the 1 is placed there, it is a miniature 1. It is placed there because all of the digits are already in their places. So if we place another large digit, it may cause some confusion. But because it is 10, we put it right here beside the 4, because 10 plus 4 is equal to 14. So it is not just a 1 that is placed there, but it is 10. And we say 10 plus 4 is equal to 14. So we are actually writing 14, but we are writing it with a small 1 and the large 4 that was there already. So that's 14. So 14 minus 7 is equal to 7. And 2 minus 2 is equal to 0. With nothing to be taken away from 1, it returns as it is. So 27 of the plums were eaten. 10 were spoiled, according to Jerry. The 10 spoiled plums must also be taken out, which further reduces the number of plums. We will subtract 10 from the previous result. So having the result of 107 plums, 10 were spoiled. So we need to reduce the number of plums by 10. So we need to subtract 10 plums. Subtracting 10 is very simple. 7 minus 0 is 7. What about here? We may rename the 1 and then put the 1 here and have 10. Or we might just say 10 minus 1 is equal to 9. So we may do it in any way we feel. So 10 minus 1 is equal to 9. So whether we rename or we cause it to remain, the result will be the same. Right, and Jerry says 9. And it is 9. The correct answer is option C. We will take another approach to the solution of this problem. Another way to solve the problem is to first add together those plums that have been taken away. So, we are taking away 27 and we are taking away 10. In all, we are taking away the sum of 10 and 27. So, what we do is add those two together and we will have the total number of plums that we are taking away. So 7 minus 0, 7, according to Jerry, Jerry is right, Jerry is saying 7 plus 0. So 7 plus 0, and that is equal to 7. And 2 plus 1 is equal to
3.
like that. Altogether, 37 plums were removed. We therefore need to reduce the total number of plums by 37. So we will reduce the total number of plums by 37. And we will begin with, we intend to say 4 minus 7. So we go to the greater place value and rename the 3, or the place value of greater significance, like we did before. And we have 14 again. 14 subtract 7, we will get 7. In this mode of subtraction, we cannot take 3 from 2. There is only 1 at the other place value. Whether we rename or not, it will be the same effect as saying 12 minus 3 is equal to 9. Because the last digit to be subtracted is this 3. There's nothing else. And we have a 2 here and a 1 there. So we may say 3 from 12, and that is equal to 9. And if we renamed the 1, we would still get 12. So we cause it to remain. So whether we rename or we cause it to remain, the result will be the same. The correct answer is therefore option C. Five cakes were cut into thirds. How many thirds were there in all? How many cakes were cut into thirds? 5 cakes were cut into thirds. How many thirds were there in all? 15. So Jerry Lewis is saying that is 15, and that is represented by option
A.
Right. So a third is 1 part out of 3. So there we have 1/3. A third is a part out of 3 equal parts. Not just 3 parts, but 1 part out of 3 equal parts. So we have the fraction well labeled as usual, so that we are always reminded and we are familiar with the parts of the fraction and what they mean. The denominator is 3. The denominator tells us the number of equal parts that the whole is divided into. The number of equal parts that the whole is divided into. Let us divide each cake into 3 equal parts, because we have 5 cakes there. So we have them divided into 3 equal parts. And each one is divided into 3 equal parts. When we divide something in 3 parts, they have to be equal, right? They have to be equal. Let us find out the number of thirds in all by counting the total number of thirds in the 5 cakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 thirds in all. There are 15 thirds in all. The correct answer is therefore option A. 5 cakes were cut into thirds. How many thirds were there in all? We are taking another approach. there are 5 cakes cut into thirds. The cakes are cut into thirds. We need to know how many thirds. We may say that the 5 cakes are divided into thirds, and as such proceed to divide 5 by a third. On the other hand, we are really attempting to determine the number of thirds that there are in 5. How many times may a third go into 5? Or how many thirds of a cake are in 5 cakes? It is the same problem. How many tens are in 30?
3.
3. How did you get 3?
Divide.
By dividing. So if we ask how many thirds are in 5, we will have to follow the same procedure. We would have to divide. So we would divide 5 by a third. 5 divided by 1/3. When working with fractions and whole numbers, the whole numbers are written as fractions with 1 as the denominator. So the whole numbers are written as fractions with 1 as the denominator. And what do we do next? Invert. When dividing by a fraction, we invert and multiply. Now, in mathematics, there is not only a single way to invert. When we are inverting a fraction, we are actually reciprocating the fraction. There is another way to invert a number, and we may invert that number by giving to it a negative sign if it is positive, or a positive sign if it is negative. So we have other inverses apart from doing the reciprocal. But we are dividing in this particular case. Therefore, finding the reciprocal or reciprocating the fraction is appropriate. So do the reciprocal or the inverse and multiply. We will complete the multiplication process on the next slide. When multiplying fractions, we first, and notice that I say first, the first thing that you do is see if the fractions can be reduced. So when multiplying fractions, we first see if there is any common factor that we may use to reduce the fractions, meaning if there is any number that we can cancel, because students use the word cancel more often than we use reduction of fraction. The denominators are equal to 1. The fractions cannot be reduced. So if we have 1, just ones in the numerator, or if just ones are in the denominator, there is no way to further reduce the fractions. So those fractions cannot be reduced. The answer will be the result of dividing the product of the numerator by the product of the denominator. As a matter of fact, this set of denominators being 1 is not the only way that we can show that fractions cannot be reduced. Fractions cannot be reduced if they do not have common factors. There is no number that can divide into the numerator and denominator. So, if there is no number that can divide into both the numerator and the denominator, then the fraction cannot be reduced. If the fraction is already in the what we call simplest form or lowest terms, then the fraction cannot be reduced. This fraction is already in its lowest terms. We are sure of that because the denominators are equal to 1. There is no other smaller number that we can reduce the denominators to. So we are sure that that fraction is in its lowest term and cannot be further reduced. The answer will be the result of dividing the product of the numerator by the product of the denominator. So any answer there that we will find from henceforth will be the result of dividing the product of the numerator by the product of the denominator. That we will always do when the fractions cannot be further reduced. So there we have 5 threes,
15.
and then the denominators will be
1.
right. So 1 multiplied by 1 is equal to 1. Any number divided by 1 is equal to that same number. Any number divided by 1 is equal to that same number. So 15 divided by 1 is equal to 15. The correct answer is option A. 5 cakes were cut into thirds. We are taking another approach to the problem. We could have taken a look at our diagram and make a calculation. Each cake has 3 thirds. How many times do we have 3 thirds?
15. 5 times.
Right. So we have 3 thirds 5 times. How many times do we have 3 thirds? We are talking about 5 cakes. So how many times do we have 3 thirds? There are 5 cakes. We therefore have 3 thirds 5 times. The 3 thirds occur 5 times. We therefore times the 3 by 5. And that is what we use, a colloquial term, times. We times the 3 by 5, which means that we multiply 3 by 5. And in mathematics, multiplication is always a possibility when we have a problem in which we have a particular number occurring a certain number of times. So 3 5s, 15. The correct answer is option A. Carl has P number of playing cards and Pat has 35. Which operation must be used to get the number of cards that they have in all? What operation will give us the number of cards that they have in all? And Jerry Lewis is saying it's addition, so we will add. So addition is the correct answer. Have in all. The key word there is all. The word is used most often when we are talking about addition. But it may also be used for multiplication. But we will decide now if it is multiplication or addition that is appropriate in this particular case. Jerry Lewis has concluded already that it is addition. We are sure that on this occasion we are not talking about multiplication because there is nothing that occurs a certain number of times. So addition is our option of choice. We have to settle with addition and it is represented by option C. A problem containing the operative term all may be a subtraction problem. That is when we have the total or the all and we need to find a portion. But as long as it is the total that we are finding, we are required to add. Let us say that Carl P cards are actually 4. So we are saying that Carl's P cards are actually 4 cards. There we have them, hearts and diamonds Heart without diamond is wrong. So, also assign 3 cards to Pat. So we will assign 3 cards to Pat also. So let us say Cal's P cards are actually 4 cards. And let us assign 3 cards to Pat. There we have them. How many cards do we have in all? We have 7 cards in all. With 4 cards and 3 cards, how did we arrive at 7 cards? We added them. So 4, something needs to go inside this square here. So 4 something 3 is equal to 7. The operands are 4 and 3. Which operator will give a result of 7? Which one will give a result of 7? Addition will give a result of 7. So addition is correct. So if one person has a certain number of cards and the other person has another number of cards, if we put them all together, it will be the same as if we are adding all of them, or adding the 2 numbers together, as we see right here in the demonstration. Which shows 7/10 as a decimal? Which shows 7/10 as a decimal? Option C. So Jerry Lewis is saying that it is C, but let us see. Grade 4 students should know to express tenths in decimal. But let us take a look at how it is done. You need to know how to, or you should know it already, how to express tenths in decimal form. But we will take a look at that in a second. Convert the vulgar fraction to decimal. How do we convert that vulgar fraction to decimal? Numbers like 10, 100, 1,000, 10,000 are powers of 10. When dividing by powers of 10, the number of zeros tells us the number of decimal places that we need to reduce the number by. The single zero tells us that we need to reduce 7 by how many places of decimal, Jerry? 1 place of decimal. In a whole number, the decimal point is located to the right. So we need to reduce that 7 by 1 place of decimal. There it is, 1 place of decimal. It is not good manners to write a decimal fraction without a whole number. If there is no whole number, then 0 will do. So when we are writing a decimal fraction, we have to ensure that it has a whole number. If there is no whole, you cannot just leave it like that, or you should not just leave it like that. You should put 0. So we have 0.7. The correct answer is therefore option C. And we have seen. Decimal. In a fraction, we consider that the numerator is divided by the denominator. So let us carry out the division process. So we are attempting to write 7/10 as a decimal. What do? We are, on this occasion, making use of the fact that in a fraction, we may treat the numbers as if the numerator is divided by the denominator. we first say 10 into 7.
I can't.
And 10 cannot go into 7 a whole number of times. So what do?
Add a 0.
We put a 0, and it cannot go a whole number of times. So there is no whole number. Because there is no whole number, we will put a point. Why do we put the point? Because everything that follows the point will be a part of a fraction. Because it will be a decimal fraction. So we say 10 into 70. And 10 into 70 goes 7 times. Why did we place the point after the 0? That's the question. We did that because there is no other digit that follows the 7 in order that we may have a whole number in our answer. The decimal point indicates that any number that will follow will be a fraction. So, when we say 10 into 7 and that did not work, we put the 0 and we put the point. Why did we put the point? Because 10 cannot go into 7 a whole number of times. So it will be a fraction. It will be a decimal fraction. So we have to put that decimal point as an indicator that the numbers to follow will not be whole numbers, but will be fractions. The correct answer is option
C.
We are going to be taking a look at the powers of 10. And as such, we need to understand what is an index. So what is an index? Every number is comprised of two components. Every single number that you can imagine is comprised of two components. So one component is the base, and then the other component is an index. So your regular number that you have like 1, 2, 3, 4, 5, they also have their base and their indices. When you do not see an index, the index of a number is equal to 1. So other names for index are exponent. Another name for index is power, which is the one that is most often used, the power of 5. Logarithm. So those are the names that are used for index: exponent, power, and logarithm. A power of 10 is 10 raised to some power, where 10 is the base. So we have 10 raised to the power of 2, 10 raised to the power of 3, 10 raised to the power of 4. And we call 10 to the power of 2, we call that 10 squared. And 10 to the power of 3, we call that 10 to the third, or 10 cubed. And 10 to the power of 4, we generally say 10 to the fourth power, or 10 to the fourth. The power or index tells us the number of occurrences of the base that are multiplied together. So the base is 10 and the power is 2. So we will have 2 occurrences of 10. The base is 10 and the power is 3. So we will have 3 occurrences of 10 multiplied together. The base is 10 and the index is 4. That tells us that we have 4 occurrences of 10 multiplied together. So to the power of 4, multiplying, we have 1, 2, 3, 4 occurrences. To the power of 3, we have 1, 2, 3 occurrences. To the power of 2, we have 1, 2 occurrences of 10. Some people will say, or some students, we have 4 tens multiplied together. It is not 4 tens, but 4 occurrences of 10, because we only have 1 10. But we may have number of occurrences of 10. When the power is 2, we have 2 occurrences of 10. And when it is 3, we have 3 occurrences of 10 multiplying together, etc. Remember that when we multiply numbers with trailing zeros, we multiply the non-zero digits, and the number of trailing zeros in the answer will be the total number of trailing zeros in the problem. Maybe that is a lot to say, a lot to hear, and may even more to internalize. But when we are multiplying numbers, especially powers of 10, or numbers that contain trailing zeros, we count the number of zeros, and the answer will have the same number of trailing zeros. Not only that, we multiply the significant digits, or the non-zero digits. 1 multiplied by 1, multiplied by 1, multiplied by 1. But no matter how many ones, or how many occurrences of 1 we multiply together, the result will still be 1. So let's go straight ahead. Any number of ones you multiply together, the result is 1. So when we multiply all of these ones, we will get 1. But when we multiply, we count the number of trailing zeros. How many trailing zeros do we have?
4.
4. The answer will therefore have how many trailing zeros?
4.
Right, so the answer will have the same number of trailing zeros. And if we have 3 trailing zeros in our product, the number of trailing zeros will be 3. So we have how many trailing zeros? 2. So 10 to the power of 2 has 2 trailing zeros. 10 to the power of 3 has how many trailing zeros?
3.
10 to the power of 5 will have how many trailing zeros?
5.
Your power of 10 will therefore be like this. The power will tell the number of zeros that should follow the 1. So there we have them with 10 to the power of 2, 2 zeros. 10 to the power of 3, 3 zeros. 10 to the power of 4, 4 zeros. 10 to the power of 2 will have 2 zeros. 10 to the power of 3 will have 3 zeros after the 1, and so on. It follows that 10 to the power of 0 will not have any 0 following the 1. So if we have 10 to the power of 0, how many trailing zeros will we have?
None.
We will have none. As a matter of fact, any number raised to the power of 0 is equal to 1. Those powers of 10 are associated with your place values. Our number system is called decimal. The prefix deci has to do with 10. So for your place value of, say, 100, you have to consider that the number should be followed by 2 trailing zeros. The 10 is related to the 10 digits in our number system. So deci has to do with 10. So the system that we use is the decimal system that has 10 digits. So when we see the word deci, we are talking about something that has to do with 10. The 10 is related to the 10 digits in our number system. The 10 digits in our number system are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Some students will say that our numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our digits are 10 digits. And the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It is because of the 10 digits that are in our number system why our place values are all powers of 10. Our place values are all powers of 10. What is the value of the 4 in the number 37.43? What's the value of the 4?
Hundreds. Tens.
Right, so the 4 will be 4 tenths. Let us magnify the number that is given to us. The number that is given to us is 37.43. And some students nowadays, they say 37.43. I do not know that that is correct because we never use decimal fractions or call them or name them in that way. 37.43. Let us introduce the place values. The decimal point is significant. Place values increase to the left of the decimal point. So the place values keep getting larger to the left of the decimal point. It should make sense that place values decrease to the right of the decimal point. So if we go right of the decimal point, we will be decreasing in place value. So if we go to the left, we will be increasing in place value. If we go to the right, we are decreasing in place values. The 4 is in the tenths position. Tenths position. The value of the 4 is therefore 4 tenths, and option B is therefore correct. 4 tenths. No surprise that place values get smaller to the right of the point. Hundredths are more to the right than tenths. They are smaller than tenths because for hundredths we have to divide by 100, while for tenths we are just dividing by 10. Now, do not forget that we have discussed it before, that the larger the number that you are dividing by, the smaller the result. So for hundredths, we are dividing by 100, and for tenths, we are dividing by 10. The larger the number that we are dividing by, the smaller the number or the result will be. Therefore, hundredths will be smaller than tenths.